Hi, welcome to Geometry. This is Mrs. Lydecker. I'm going to try really hard to film a video going over the material we learn in class, and I'll post it on the Ren website so that if you miss a day of school or if something happens with Corona and you have to stay home and do school at home, you can go to Ren Web and watch these videos. What you'll need to do is print off the needed materials for class ready to go in front of you when you watch these videos, because I will be using them um, in our lessons. So if our lesson today, for example, is chapter 1, lesson 1, then you'll have to go to the documents tab on RunWeb, find all the 1-1 pages, all the files for chapter 1, lesson 1, print them off, and then have them in front of you ready to go. So if you need a second, pause your video, go get that stuff printed off and have it in front of you. If you are just watching this as a review, you can probably skip the beginning of the video and get to a part where we start going over the lesson together as a review. So hopefully you have the 1-1 study guide in front of you. I'm going to share my screen here and we'll go over this together. So here is the 1-1 study guide. What we're going to start looking at today is just being able to identify parts of geometry, the basic foundations of it. So points, lines, and planes are going to be our main focus today. To introduce you guys, let me stop sharing my screen here for a second. So a plane really is just a flat surface that goes out forever and ever. So I have a piece of paper here that's kind of an example of what a plane is. So a plane could be like this, horizontal, could be vertical, it could be sideways, diagonal, right? All kinds of positions this piece of paper goes, it is a plane. So some examples of planes in real life would be like the surface of a box. And this box is made out of several planes. We've got 2 on top, right? And then 4 on the side. And so this is made out of 1, 2, 3, 4, 5, 6 planes. So the technical definition of a plane is it's a surface that goes out forever and ever. So these planes here, they're confined. They stop right here. But the technical term for a plane in geometry is a surface, a flat surface that goes out forever and ever and ever. Okay, so the second thing we want to know is what a line is. So I've actually got a piece of string here, some yarn here to show you what a line is. Now a line is basically 2 points that are connected, and well, a line, the technical definition is it goes out forever and ever and ever. So if this line, if I keep going and going and going and going all the way to touching my wall back there or wherever I want to go, this line technically goes out forever and ever and ever. So a line can cut through a plane. I could have this line cut through this plane, and they would intersect. If I have this intersecting my plane, it would intersect at one location, one point. So that brings us to what a point is. So here on our study guide, we draw a plane using a kind of a parallelogram surface to show a plane. But what we have right here is a plane, and technically this goes out forever and ever and ever, but we're just going to draw a surface so that we can see that this is our plane. And then of course we've got our line, and these arrows show that it goes out forever. It keeps going. So technically it goes out both ways like that. So we a lot of times we'll name our plane with a capital letter, and we'll just write that on the side. So the name of this place is, or this plane is plane N. And then our line, we're going to use 2 points on our line to name it. So a point is just one location, one dot. We've got a point D right here. Now that's not on a line. That's just literally a point on my plane. But anytime I have 2 points that are connected, that is called a line. So my 2 points actually I have 3 points here. So I've got point B, and point C. They are all connected. So I could name this line by any of these 3 points, as long as I have 2 of them. So I could say it's line AB, and I'm going to actually draw a line on top of the 2 letters to show that it's a line, and the arrows show that it goes out forever and ever. I could name it BC, or I could name it AC. Now, could I reverse these letters? Would that be okay? Sure. So there's actually technically, I guess, 6, or even, we're going to say in a second, 7 names for this line. So you've got many, many options, and they're all correct. So these are all names for this specific line. Now, do you see this letter L right here in cursive? This letter L right there. That's another way to identify a line. And so we can also call this line L. I'm just giving myself some space by erasing. So this can also be called line L. So we've got a line here, a plane N, or point D. So we've got lots of parts here. Now, a plane can also be named using 3 points, because anytime you have 3 points, if you connect them, it becomes a plane. See how this becomes a triangle? And think about if this triangle goes out forever this way, and forever this way, that triangle becomes a plane. So we can also name a plane using 3 points. And so here, section B, this example B here says, a plane, use the figure to name each of the following. So it says, name a plane containing point D. Well, the plane where point D is located is this plane right here. So I could use N to represent that. I could name it ABC, or ABD, or ACD, right? I couldn't use any of those to show that these 2 are, these 3 points all make a plane. And actually it's not going to be ABC, because ABC makes a line, so that's not going to be included there. Maybe I could say BCD. So if we read this, it says, a plane can be named as plane N, or can be named using 3 non-collinear points. Non-collinear means not on the same line. So they cannot be on the same line. So when I said ABC here, that was actually wrong. That was a mistake there. So not ABC, because if I put all these ABC, they're on the same line, and that would defeat the purpose of calling this a plane, because really what this is a line. All right, so let's do some examples. Number 1, name a line that contains point A. So point A is right here. If I want to look at a line that contains point A, well, quite obviously it's right here, right? It's not going to be this line right here, because A is not on it. It's not touching this line. So I could name this line AB. And don't forget to put your arrows on top on your homework. Please identify the line by drawing it on above the letters. I could name it BC. It doesn't even see point A. Technically, I don't even have to have the letter A and the name of the line, because BC goes out forever and ever, and it's going to cross through where A is. So I could say BC. I could say AC. Any of those would work. Or I could say line L. So all of those would be options. And then, of course, if you want to reverse these letters and write BA, CB, and CA, that would work too. Yeah? Okay, let's look at number 2. What is another name for line M? So we've got line M here, another name. We could just name it either BD or DB, right? Because we have to use 2 points to name the line. So this would be like BD, and then draw my line on top, or DB. Number 3, name a point not on AC. So any point that's not on this line, not on AC, would work. So I could say E or D. So I could say E or D. Number 4, what is another name for line L? Okay, here's line L. Now, line L is right here. That would be the same thing as number 1. So any naming the line that has point A, all these answers would go for number 4. So that would be options, that would be correct for number 4. Number 5, name a point not on line L or line M. All right, so I don't know if I can erase any of that stuff, but let's use a different color here. So I'm gonna use green. I've got line L right here, and I've got line M right here. Now, points that are on those lines would be A, B, C, D. All of those are on the line, except for E. So a point that's not on either of those lines would be point E. Maybe we could say point E right here. Okay, draw and label a figure for each relationship. So we need to draw a picture that describes all this stuff right here. So we've got AB is in the plane Q. So that means I need to draw point A, draw point B, and then have it go through here. And I've got a plane. I'm going to draw it pretty big just in case I need more room. There's my plane. And I'm going to name this Q because they've asked me to name it Q. So this is plane Q. ST intersects AB at P. All right. So let's say I've got a point. I'm going to actually draw this longer. So I've got a point P right here. And it says ST intersects at point P. So this is my line. That's intersecting, meaning crossing over S and T. Sorry if my drawing is not the greatest. And they intersect at point P. So this is the place they cross over. Point X is collinear with points A and P, meaning X is on the same line as points A and P. So I have point A here, point P here. So that means my point X has to be on this line. Let me read this next one just in case. Point Y is not collinear with points T and P. So I'm going to draw X maybe right here. X is right here, collinear with A and P. And then T and P. Y is not collinear. So that means my Y, point Y, cannot be on this line. If it's on this line, it would be collinear, and that would be contradicting the statement. So I'm going to put Y maybe right here. And so I've got X and Y. And then my last statement says line L contains points X and Y. So points X and Y, this actually, that's the same line as what AB would be. So I'm going to name this line L. So a name for line L could also be AB, it could be XY, it could be BY, it could be AP, right? There's lots of names for line L. And so it's most convenient if we have a letter to the line rather than just using the points. But okay, so that's an example of the drawing. You could have drawn it differently. It might look different from mine as long as it has all these statements truthfully drawn on the plane, you're good to go. Okay, let's take a look here. Now we've got planes that intersect. So what if I have a piece of paper, right? Maybe I just have this little brown piece of paper and this white piece of paper that I used earlier, and they intersect, meaning they cross over. So even if I had maybe cut out a section here on this piece of paper, and I have them intersecting. So literally just doing it right here in front of you guys. But I've got my planes cutting through each other. So if you can see, I don't know if you can see it right here, they are cutting through, intersecting. So what's interesting is when two planes intersect, they actually create a line, because the place where they overlap, where they two overlap, I'm gonna just draw a line right here where they touch. That is, by definition, So if I draw where they intersect with a purple marker, I don't know if you can see it, where they intersect, what you see here is they touch, they cross over at a line. So the intersection of two planes is a line. The intersection of 2 points, though, if I draw, intersection of 2 lines, if I draw 2 lines, line here, like we talked about earlier, the intersection of 2 lines would be a point for P. But an intersection of 2 planes where they're touching would be a line. Let's use these exercises to kind of go through our lesson. So number 1, name the intersection of plane N and line AE. So here's my plane N and AE. So AE is going all the way through. These dotted lines show that it's actually cutting through where it's like on the bottom, the lines on the bottom. So if an example, like using this thread here to show that, it would be like a picture showing there's the line and then the bottom dotted part is on the bottom. So the intersection of plane N and line AE is right here at B. Name the intersection of BC and DC. So BC is right here, DC is right here. Where they cross over is at C. Does DC intersect with AE? All right, good question. So here's DC, this is my line, and I'm going to use red to show AE going all the way down. Now, think about this. AE is going up and down, and DC is on my plane. So for example, I have my plane right here. That's my line, DC, and it's horizontal like this. AE is vertical. It's going through up and down. Do they cross over? They don't. So imagine if this was in real life and you're picturing it in your head. They don't intersect. So they do not. They do not. And you could say DC is on plane N going horizontally, and AE does not touch DC, and it goes vertically. So you can just kind of describe why do they not intersect? Sorry, my handwriting. So it goes vertically. There you go. All right, now we have a box, a bunch of planes all connected. Name the 3 line segments that intersect at point A. So I've got point A right here. We want to look at line segments that intersect. So any line that has point A would be a line segment. This is a line segment that has point A. This is a line segment that has point A. And then this is a line segment that has point A. So I'm going to say this, GA, DA, and BA. Now, a segment is a part of a line that doesn't continue forever and ever. It stops. So notice when I drew my line here, I didn't put arrows because the word segment means it's just one section of it. It's a section of a line. So it stops at G, stops at A. That's the part of the line, which we call the segment. Number 5, name the line of intersection of planes GAB. So let me see, GAB. They used 3 points to name the plane. Remember, we can use that. So 3 points that name this plane is right here, this top part here, that's G. So name the line of intersection of planes GAB and FEH. FEH, that's right here. I'm gonna use a highlighter so we can still see what's going on. Here's FEH right here. This plane, saying name where they intersect. Well, don't they touch right here? That's where they intersect. Remember, where they intersect is a line, so we're going to say it's line GH. Number 6, do planes GFE, so GFE right here, the blue plane here, and HBC intersect. Let me use yellow. H is right here. Oh, actually, oh, I need to probably erase that. HBC. Yeah, so H is that. Do they intersect? Do they touch at all? Well, it looks like they do. It looks like they touch right here. So yes, they intersect. They intersect at HE. They intersect at He. All right. That's all I have for you for Chapter 1, Lesson 1. You can find the homework on RenWeb. And don't forget to do Chapter 1, Lesson 2 in just a second. I'll put another video up for that.